This is the Algebra 2 lesson for the first day of section 1.6, and it's about absolute value equations and inequalities. And just a reminder that absolute value is just kind of a couple of thick bars on either side of whatever number we're trying to evaluate, or in this case, sometimes a variable. So our objective is to write and solve equations, inequalities, involving absolute value. So getting a feel for what does absolute value do when we're talking about our equations and inequalities. So absolute value is the distance from zero on a number line, how far something is from zero. So what that means is there's going to be two answers for everything that we ask about. I mean, this is on the number line. If I say that I want a number that's 2 units away from zero, that could be 2, but it could be -2. And we never speak of absolute value as a negative. It doesn't make any sense. If you tell somebody, I drove 13 miles to Big Lake last night, and then I drove a -13 miles back. No, that doesn't make any sense. It's the same distance either way. So distance from zero on a number line. In the little blank there, we're going to put it's non-negative. Well, doggone it, why didn't they just say it has to be positive? Because that would have left out zero. So non-negative. So if we look at this problem that they have right here in this next position, in numbers, they want to know what's the absolute value of 4. Well, it's 4. Because it's 4 units, 1, 2, 3, 4 units away from zero. But what is the absolute value of -4? 1, 2, 3, 4 units away from zero. So it's always going to come out positive. In symbols, the absolute value of x equals x if x is greater than or equal to 0. So if x is positive, if the number we put in for x is positive, obviously it's going to be positive when we kick it out of absolute value because it has to be. It's a distance. But when they give us a number that's less than 0, and that would be a number that's negative, and we put it in here, well, what it's going to do is we're actually going to need the opposite of the negative. So this would be the opposite of a negative, which of course will make it positive. So just a little definition there, a little algebra of what we need to do. But part of this, understanding this first section, this first portion of the section, is that we are going to have two answers. I mean, that's absolute value. If I ask you for a number that has an absolute value of 6, well, there isn't just one. 6 and -6 would both have an absolute value of 6. So absolute value equations have a variable inside the absolute value symbol, and these equations can have two answers, and we have a little example there. I ask you for something that has the absolute value equal to 5. Well, there are two of them. -5 and 5 are both 1, 2, 3, 4, 5 units away from 0. So this distance stays the same. Right there. So what we need to do, what we always need to do, is get to the point where we have absolute value all by itself. And that's called isolating. So we are going to isolate the absolute value. Sorry, you can see my writing got really weird here. We just had a fire alarm go off. So isolate the absolute value. Scared the dickens out of me. All right, so we have to get the absolute value bars by themselves on one side when we are going to solve. So next up, it says we are going to solve and graph absolute value of 2x plus 5 equals 9. Okay, so I think, all right, let's see here. 9. And they said get the absolute value all by itself. Well, the absolute value is by itself on the left-hand side of the equals here. That is by itself. But I'm supposed to have two answers. So I stop and think. I'm saying this is the problem and this is the answer. But if the answer for absolute value comes out to 9, that means it also could have been -9. So we're going to have to rewrite this as two separate equations without the absolute value bars. And that's the part most people forget. So a nice way to think about this, well, okay, not really a nice way, but a good way to remember it. Years ago, we had asked some students, you know, how could you come up with a story that would help people remember this? And Mrs. Peterson's students had a great one. They said, think of the absolute value as prison bars. So you've got prison bars. And everybody knows that any good convict will always have two escape plans. So you've got to have the negative and the positive. It's kind of like a north and south escape plan. And that was one of the ways that her students were able to remember that whenever you have an absolute value equation, you have to set up two equations. You have the positive and the negative. So we rewrote those without the absolute value symbol. And then we just solve them. That's what we do. We solve them. So you solve each equation. Right now we have 2x plus 5 equals negative 9, and we have 2x plus 5 equals positive 9. Well, I want you to put a big star over here on the side next to these, because this is what people mess up on the test right here. And that is getting those two equations. You need two of them. So we're going to have to subtract 5 and subtract 5 and divide by 2 and divide by 2. And then realize, hey, that means both of those work. Huh, let's check that. Let's go put a negative 7 up in that original and a 2 in there, and let's see what happens. So if we go back up here and we put a negative 7 in, it's going to say the absolute value of 2 times negative 7 plus 5 equals 9. Well, let's see. This would be negative 14 plus 5. Negative 14 plus 5 is negative 9. Is the absolute value of negative 9 9? Yeah, it's 9 units away from 0. All right, and the other answer we had down here was x equals 2. Let's give that a try. Absolute value of 2 times 2 plus 5 equals 9. Okay, that's going to be 4 plus 5. Hey, that's 9. Yeah, the absolute value of 9 is 9. So like I said, I want you to highlight this part right here. 1, 2 equations, because that's the piece that people forget about. It's not the solving. We've done the solving before. That's not the big deal. And then last but not least, it says graph those solutions on the number line. So we put a dot at negative 7, and we put a dot at 2, and there it is. We graphed our answers. Now, down here at the bottom of the page, it says check your solutions. Again, I already did that up top with you because I had to be able to see the original. But hopefully you're writing that stuff down there, you know, so you can see, hey, this really works. So we plug them in and we make sure that both sides of those equations come out to be exactly the same thing. So, two keys to these. You can write over here on your lines. Two keys to abs value. 1. Isolate abs value. You have to have the absolute value all by itself on one side of the equation. 2. Two equations. Not just one. But in order to figure out those two equations, you have to have the absolute value all by itself first. So when we look at this new one up here, 3 times the absolute value of x plus 2, all of that minus 1, I got to get rid of the 1. I have to think order of operations backwards, and I have to move that over by adding 1. Then I have to divide both sides by 3. Now I've done step 1. I have that first key element for absolute value. I've isolated the absolute value. It says absolute value of something equals a number. Now I make my two equations. Now I make my jailbreak. 2 escape plans. a negative, and a positive escape plan. I'm going to subtract 2 all over the place. I'm going to graph them. Just putting them on the number line there. Want to make sure that looks like it's been filled in there. And then we should check them. We should make sure that they are absolutely going to work. So let me get this down here a little bit, and I'll just rewrite it. We had solve and graph 3 absolute value of x plus 2 minus 1 equals 8. And we said there were 2 answers, negative 5. So 3 times the absolute value of negative 5 plus 2 minus 1 equals 8, and positive 1. Now, all I'm doing with the parentheses in the second one, well, actually in the first one too, is using them as a placeholder to show, hey, that's our answer. That's what we're putting in there. We said it was negative 5 and 1. Alrighty, so this will be 3, and absolute value bars are like grouping symbols. You have to do them first. So negative 5 plus 2 is negative 3, minus 1 equals 8. The absolute value of negative 3 is 3. So this will be 3 times 3 minus 1 equals 8. Well, that's 9 minus 1, and yepperdoodle, that equals 8. So that one checks. Then we go to our second answer, which was 1, and we say, all right, well, the parentheses in there, they're not really doing something. They're just a placeholder. So this will be 3 times 3, because the absolute value of 3 is 3, minus 1 equals 8. And if that looks familiar, it's because we just did that. They both work. Checkable. Key elements. Isolate the absolute value. Get it by itself on one side. Then we have to split it into 2. So notice it says get the absolute value symbol alone on one side before splitting into 2 equations. So what do they mean by that? We have to get rid of those 2 numbers. And we're going to use the order of operations backwards to do that. We're going to add 1 to both sides, and we're going to divide by 3. And there we go. Alrighty, next page. These take up a lot of space, so I'm going to take quite a bit of paper for this section. The got it. This one is for you. Go ahead and pause the video and work your way through it. Just do A for now. As you start it back up, hopefully you're saying to yourself, all right, key element number 1, there are those absolute value bars. It is isolated. It's over on the left all by itself. So jailbreak, a negative and a positive. And then we solve them. So we're going to subtract 2 all over the place and get 3x equals negative 6 and 3x equals 2. And then we're going to divide by 3. Oh, fractions. Well, yeah, fractions happen. There's not much we can do about that. So we'll go ahead and put a big dot on negative 2. But at 2/3, we know it's going to be closer to 1 than it is to 0. It's not on our interval, so we better go ahead and label that one. We better let people know, hey, that's where my little 2/3 is. Absolutely checkable. It's another one that you certainly could check before you hand in your test and make sure everything is going to work. Now, B is a little tougher. B is a little tougher. Remember your 2 key elements. Isolate the absolute value, then make your jailbreak. Got to have 2 plans, 2 ways out of the jail. Go ahead and pause the video and try this one. All right, step 1 is isolate. That means we have to subtract the 3. We don't have the absolute value bars all by themselves over here. Make those a little thicker, I guess, so they don't look like 1s. And then we have to divide by 2. Now we have isolated the absolute value. It's on one side all by itself. So the next thing we have to do is say, all right, could be negative 2, could be positive 2. those are the things that could happen here. That's our jailbreak. 2 bars, 2 escape routes. Subtract the 9, subtract the 9. So we have x equals negative 11 and x equals negative 7. And again, just go the number line, although this time our number line needs a little help because we didn't get out here to negative 11. And we put a dot on negative 11. And we put a dot on negative 7. And we have graphed our solutions to those equations. So it's not so bad. Hey, we've done a lot of this before. Yes, it's just those 2 key elements that I had you write down for this objective. We have to be able to isolate, and we have to be able to recognize that it's going to have 2 solutions. Otherwise, our objective, working with this absolute value stuff, we're not going to be able to do it. So it says some absolute value equations will have no solution. Here's an example. What this says is, give us a number so that when we take its absolute value, we're going to get a negative 5. Ding, 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 your little bell goes off in your head and you say, wait a minute, that can't happen. No, it can't. It doesn't have any solutions. You can't take the absolute value of something and have it come out to be negative because it's supposed to be a distance something is from 0. So, second little bullet here says always check for extraneous solutions using the original equation. Extraneous is our fancy math word for false solutions. You do all the math right, but you plug it back in and it doesn't work. We have to do that with absolute value. Now you'll notice I didn't check a couple of these just because I didn't want to take more of this video time to do that. But we really need to check every problem that we use absolute value for. We need to do that. So problem 3 says we're going to solve and check this for extraneous solutions. And key step number 1 is to isolate the absolute value. The good news is it already is. It's on the left side all by itself, no more numbers on the left side of this equation. So now I say, all right, self, I'm supposed to have 2 answers here. So 3x plus 2 equals, oops, well, it could be a negative 4x plus 5, or it could be a positive 4x plus 5. So on the left we have 3x plus 2. We have to distribute the negative. It's like a negative 1 times everything, or you can think of it as the opposite of everything in the parentheses. Whatever works for you. And then we say, well, we got to get the x's together. I'm going to go ahead and add the smaller of the 2 to both sides to keep my x positive, like some of you are always taught to do. And then we would have to subtract 2 from both sides. And then divide by 7. And we know we have to check that answer, but hang in there. Let's get the other one also. So this time the 3x is now the smaller of the 2. And we're going to subtract 5. So x equals negative 3. Now, what we need to do is plug them back in and see if they work. Absolute value of 3 times negative 1 plus 2, is that going to equal 4 times negative 1 plus 5? Well, let's see. 3 times negative 1, that's negative 3. Absolute value of negative 3 plus 2 equals 4 times negative 1 is negative 4 plus 5. Okay, so we need the absolute value of negative 3 plus 2 is negative 1, and negative 4 plus 5 is 1. Is the absolute value of negative 1 equal to 1? Well, yeah, absolute value of negative 1 is 1. Cool, one of our answers works for certain, and that is the negative 1. That answer is definitely going to work. Now let's try the negative 3. Absolute value of, let's see, what was it? It was 3x plus 2. So 3 times negative 3 plus 2 equals 4 times negative 3 plus 5. So we're going all the way back up there to check and see if it works. So absolute value bars, a lot like parentheses, 3 times negative 3 is negative 9 plus 2. And then we have 4 times 3 is negative 12. Negative 12 plus 5 is negative 7. Well, let's see what's going on down here. I shouldn't skip steps here. Let me go ahead and write that down so that nobody gets lost. Negative 9 plus 2. That's going to be negative 7. So absolute value of negative 7 equals, let's see, negative 12 plus 5, that's negative 7. All right, absolute value of negative 7 is 7. It is 7 units away from, 0. And look at that. We're saying that 7 is the same as negative 7. No, it's not. That answer doesn't work. So we just did all the math right, but one of the solutions that we had does not work. That's called an extraneous solution. So this one was extraneous. You know, like I said, we did all the math right. We had 2 solutions, but only one of them worked. So we give them the one that works, and that's going to be x equals negative 1. Little got it here. So what I want you to do is go ahead, think through those key steps, isolate the radical, then make your jailbreak with 2 escape routes. Go ahead and pause the video. Make sure you check your answers. All right, with this little doggy, we'd have to have 5x minus 2 equals the negative of 7x plus 14, and 5x minus 2 equals 7x plus 14. All right, well, I've got to distribute the negative over here. So again, that's like a negative 1 times everything over there. And then I would go ahead and add 7x to both sides, and that would be to keep my variables positive. And then I would add 2 to both sides, so 12x equals negative 14 plus 2 is negative 12. Divide by 12, and x equals negative 1. Maybe. We'll have to check that out in a little bit. Second one, we're going to go ahead and subtract 5x from both sides because that's the smaller x value. So negative 2 equals 2x plus 14. And then we'll subtract the 14 from both sides. So negative 16 equals 2x. And we divide by 2. And x equals negative 8. Now, we better check those out. We better plug those back in. So let me scroll this up a little bit. Too much, smartboard. There we go. Absolute value of 5 times our little negative 1 minus 2 absolute value equals 7 times negative 1 plus 14. Okay, well 5 times negative 1 is negative 5, so absolute value of negative 5 minus 2 equals negative 7 plus 14 because 7 times negative 1 is negative 7. This will be the absolute value of negative 7 equals negative 7 plus 14, which is 7. And we get here and we realize, yep, that's going to be true. This is going to say 7 equals 7. This one is a go. Little x equals negative 1 is going to work. Now that doesn't mean the other one is not going to work. I mean, we had several equations already that we've done that had 2 solutions and everything was great. So absolute value of 5 times negative 8 minus 2 equals 7 times negative 8 plus 14. Let's see what happens here. 5 times negative 8, well, that's negative 40. And 7 times negative 8 is negative 56 plus 14. Well, let's see here. Negative 40 minus 2, that's the absolute value of negative 42. And negative 46 plus 14 is negative 42. But, we still have to do the absolute value. And the distance that negative 42 is from 0 is 42. Oops. Doesn't work. It is extraneous. It is extraneous. Not going to happen. So, as I mentioned earlier, when I went through the notes here, there were a couple of them that I didn't go through and check with you. Absolutely should do that, but because this is on a video, I didn't want to take the whole time to do that. I'm hoping that this video will be a little bit shorter for you here. And actually, you should stop and think, do I feel like I've got a good handle on that objective? Because this is the end of day one. So it was to write and solve equations and inequalities involving absolute value. We didn't do inequalities today, we just did equations. So tonight, before you go to bed, I want you to write down on this section, on the summary pages, what are those 2 keys to solving absolute value? 2 keys, all right? Things that'll open the door for us and make it easier to do these problems and make it so that we can do them correctly. So remember, that's going to be isolating your absolute value, and then we need 2 solutions, a positive and a negative, because 0's right smack dab in the middle, So lesson 1-6, day 1, page 46. Go ahead and do 11 to 23 the odds, 43 to 51. Reminder, show all your work. No work equals no credit. And make sure that they're all right. Check all your odds in the back of the book. And when you come back, we'll take care of those few evens that you have here to check. But make sure everything is going right.